Let's do some advent of code. So I wanted to stay up and do day 19 at midnight, but I was tired. I wanted to get back into the midnight ritual, but I was tired, and it's just having a 2 year old, almost 2 year old, is how capable of staying awake you are. Here we go. Oh, the hot springs. This I remember this one. Okay. Viciously, absolutely nothing goes wrong as you begin careful search of vast field of helixes. Could this finally be your chance to visit the onsen? Oh, okay, that's right. Because yeah, apparently they've heard range their towels. They'll let you in for free. Every towel at this onsen is marked with a pattern of colored stripes. There are only a few patterns. For any particular pattern, the staff can get as many towels with that pattern as you need. Each stripe can be okay, white, blue, red, backer, green. So a towel with pattern green would have a green stripe, and a red stripe in that order. You can't reverse a pattern by flipping a towel upside down, as that would cause the onsen logo to face the wrong way. Okay. The orb or ob, the oob, the oob. Okay, the oob has produced a list of designs, each a long sequence of striped colors that they would like to be able to display. You can use any towels you want, but all of the towel stripes must exactly match the desired design. So the display design RGRG, you can use two RG towels and then an R towel. Okay, this is a searching pattern. All right, this is a searching problem. Um, okay, real quick, because this is definitely going to affect how I think about this problem. Is Okay, so I want to look at what is my longest towel. So for instance, here's one of 7. Um, because the longest towel is going to affect my search. Like here's an 8. So I mean, part 1 seems like a brute force. 6 of the 8 designs are possible with the available towel. Okay, we're just looking for possible. So we don't even need to find. So we don't even need to find like how many combinations. He says, guessing what part 2 is going to be. But this seems actually pretty straightforward because you're just going to do a recursive algorithm. So here is the recursive thing. It's going to be um, fun. So we're going to do val vowels equal. Actually, late init var vowels, and we're going to do this is a list of string and the lines. So line 0 dot split on, and it looks like it's actually comma space. Hooray, advent of parsing. Dot. That's actually it. Line. Right. Sorry, just compiling. We've made a new file. So right, we got my towels. Yay. And then from there, it's actually a pretty straightforward um recursive algorithm. It's just going to be so fun uh search, and it's going to take in the target, which is a string, and I'm debating if I want to search like by if it would be optimal to search by length in descending order, just to try to look for like quick exits. So um, dot sorted by. I don't actually know that this is better. To be clear, it dot length dot. Nope. Going to be target string, and this is going to return a boolean, and it's just going to be right. I haven't called that function yet. Why am I just incapable of seeing compiler errors? There we go. Okay. And from there, it's just going to be, okay, so for owls, so first, it's just going to be, what would be my base case? It would be if target.length equals 0, then return true. Oh yeah, use is empty, just, okay, that makes sense. And then, else for owls for owl and towels. Sorry. I am just writing pseudocode and getting confused when it doesn't compile because I'm a fucking bald idiot. Just a bald, ugly, dumb man. That is what I am today. So it's going to be if. Actually, let's not. I just realized like I'm going to be creating a ton of strings this way, and that is what we call a bad idea. So we're going to do int because that's just going to be starting index. That's a bad idea because it's doing a ton of memory references when really I can just treat this as a string and just a single string and just keep passing it. And that'll actually end up being quite a bit faster. So if um, val, so it wouldn't be target is empty. It would just be target if starting index is greater than or equal to target dot length, then return true. Okay, so from there it's if target dot substring, and it's just going to be start. Why in God's name would you think I'd want to start at not starting index? Okay, dot starts with Howl, then just return search target starting index plus towel dot length. Actually, do this. It's if it starts with towel and so this is a depth first search, right? Because we're gonna search um then we return true. However, if I go through the whole loop and I never return true, then return false. And then from there, it's just, okay, so patterns equal lines dot sublist, not one line size, but two, because there's a blank line in there. Okay, yep, dot filter, no, dot map, hit dot trim, just to make sure we're not gonna get any trailing white space bullshit. And then we pass patterns to this, and it's just return patterns dot add this to the thing, and that's just return patterns dot count search it 0. And run. Yep. Okay. Pretty straightforward. This is a really easy for day 19. I feel like. I say that knowing full well I'm about to eat every word I just said because this is big. This is really big. But I think doing the longest first is a good idea. I think it is. We'll test that. Okay. Yep. I am now eating those words. Yep. 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 Um. Oh, but hang on. Let's break out our good old friend caching. Val. Yep. Good old caching. Caching. Val cache equals mutable map string boolean and int. Oh, it's the same string every time actually, so I can just do int boolean. And then we're going to cache actually let me take, yeah, it's the same string every time because is it? Wait, no. Right. Okay. I know what I know how to do this, and it's gonna look ugly. I apologize to everyone for what you're about to witness. This is gonna be what we like to call in the business shit code. This code is going to be ass, and shit, a combination thereof. So cache equals mutable map of. Okay. And I'm just resetting the cache before each search. Why? Why would you do this? And actually, come to think of it, the cache can be an array. Can't it? Well, on the other hand, it. Hmm. Hmm. Do I? Because I'm trying to think. Do I even get anything out of caching true? I'm not convinced I do. Because if we hit true, it's just going to recurse all the way back. Like if we hit true, right? But I can cache the false. and not target length. I think this is right because there's no advantage to caching true because the point is true is tail recursion. Like if it returns true, then it returns true to the next level, which returns true to the next level, which returns true, right? And so, yep, just needed some good old-fashioned caching. It's just the Swiss Army knife of recursive Advent of Code problems is just add a cache. Staff didn't really like some of the towel arrangements you came up with. Avoid an endless cycle of towel rearrangement. Maybe you should just give them every possible option. Fuck you, Advent of Code. Fuck you to death, Advent of Code. I knew this was coming. It's actually the same problem though. It I laugh, but it's the same problem. It's it's the same code, right? In fact, I can just manipulate this existing one to return one, and this is now an int function. And then instead of returning a boolean, I just return it. It's exactly the same code, and now it's just greater than 0 in part 1. So I got mad, and then I realized how easy this is. This is shockingly easy for a day 19. This is like kind of day maybe mid-teens. Like 19, you usually start to get into some pretty gnarly stuff in my experience. But like last year, what was 19? I'll look it up after I get this done. Cache return. Because before I was only caching false, but now it's just a matter of okay, return cache. This, by the way, means assert not null. So with maps in Kotlin, by default they return an optional. Uh, and so I'm asserting not null, which throws a null pointer exception if it is null. That is to say the key is not containing. So that's why you always wrap that in this kind of thing. There's also the Elvis notation, which is if not null, and that's the question mark colon. I don't know why it's called Elvis notation, by the way. I don't. Return. So now it's just val result equals, and then we cache the result. Because it's still, yeah, it's still just same starting index. Cache the result. Oh, now we no, no, now we have to get a sum though. So Powell.sum of. Oh, this could be a lot more computationally expensive. Ah, this may not be easy. Me may have spoken too soon. Me may regret what me just said. So what I'm doing here, by default, there's this implicit return statement on the last expression, which this is all just one expression. So if it doesn't start with that, just return 0. Otherwise, we search. But then I still need my cache, so that's going to be starting index. Let's do it this way. Patterns.map dot size. And what I'm going to do is I'm just going to, before I do part 1, I'm actually just going to do this. Patterns.map, and this is going to be val results equal. And then now I just pass in results. Return results dot count it greater than 0. And then part 2, so now I can move that up. Part 2 is just return results dot sum. And I'm going to guess this is not going to work. This seems too easy. Yes. Yes, Colby, can I help you? Okay, good to know. Can you not? Can you just not be the way that you are? Sorry. Cats are just going absolutely mental over nothing. List Boolean. No. 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 That should not be a list Boolean. Oh, yes. Search it. There we go. All right. No, Colby. I don't like it when you behave this way. Am I still? Yeah, okay. I'm still resetting the cache. All right. Yeah, still pretty fast. I mean, half a second. I'm sure there's some kind of optimizations I could do. Probably like, take advantage of the fact. Like here's maybe an optimization. So the smallest, the smallest is 1. I mean, I could probably do some type of like hashing though, of like hash the first 3 things and then like look at the first character and go to that hash map, or do some kind of like tree structure where I build the tree from these things and I just step down the tree, and maybe that's faster because then I'm not doing this contains loop because it's all the trees already built out. That might be the best way to go, is just build a bunch of trees out of, how do you think? It wouldn't be a binary tree, to be clear. It would be just a tree where like R is the root, and then RB, and then the only issue is I don't know if, I mean, I know for certain like not every single letter's there, because if there were every single letter combo, it would do that. I don't know. That might be an optimization. I might try that just for funsies, not right now. But that might be something I do like over the summer, because I'm going to revisit these in the summer, because I want to do like a YouTube series, sort of going over like Advent of Code in July or something. This is the nonsense idea in my head. Let's make sure I'm right first. How about that? Let's make sure I don't suck at my job. Answer is too low. Okay. Whoa. Too low. How am I getting too low? Hang on. How is this too low? I'm still getting 152, right? Let's make sure I didn't break my first answer. I did break my first answer because now I'm only getting okay. So wait, that is enough, Colby. That is quite enough. That is actually significantly more than enough. Beyond enough. How am I wrong here? I broke something in my. I'm not actually gonna throw something in my cat. Don't worry. Just shooing him off. Okay. I broke something in this. All right. If I hit the end, yay! I found a combo. Return one. Else, if it starts with the towel, then we search. Right. This part seems fine. Else 0. Right. And substring. That's right. How did I break this? How is this wrong? Because I broke this for part one, right? So I actually broke it. So this is a bug. Null pointer exception. That would be because I did that's inputs. Okay, even more frustrating. I'm getting the right result. Okay. But I'm getting the wrong result now. So my puzzle output was 300 and now it's not. So I'm doing sum of, so if target.substring starts with tal, right? Am I avoiding allocating a string here? Or am I just allocating a string? At this point, maybe I need to do a car array. I think I'm creating a string here. So I probably would replace this with an array if I were really looking for improvement. But before I do that, let's actually figure out what's wrong. For tal in towels, we're resetting the cache each time. Yes? Yes. Okay. So for each towel, if it does not start with the towel, return 0. If it does start with the towel, return search. And if we hit 0, we found 1. What am I doing wrong? Because the count was working, right? The count was working. And now it's not. Like, I clearly have some bug. I just have no idea what it is. but I've broken part one as well. So search part one. This is what I had. I had if starting index equals target.length, return true, else, so else towels dot for each towel if we did, like, I'm trying to figure out where I'm wrong. I'm trying to remember what I wrote, and I wrote if target dot substring that, then we return true, right? Because we can return early here. Dot starts with towel. Right, return true. Okay. This is what we had. And print line get part or part one search part one, and then let's do val secondary cache equals, and it was mutable int to boolean, right? And this is just map int to int, which in hindsight I should just do as an array, but so it was val part one equals, and it was patterns dot count it I'm not going to feed you if you keep acting like this. Exactly, right. You're right. It 0. Yeah. This was what I did. It was print line part. And I do have to put the cache in there because um now we're somehow getting 400. Probably not a good sign. Oh, because I'm not resetting my cache. Right? Also, I'm not even using my cache anyway. So that's probably what's going on there. Now I'm getting a completely different answer. What in the hell is going on here? No, that's why am I returning true? It's part one tal starting index plus tal.length. Now I'm getting a different result again. Okay. Return true. For each towel, if target dot substring starts with towel, then we search deeper. Oh, I'm returning. Right. That's why I had the and. Yes. Okay. And maybe I'm doing the same mistake here. Um. And then that's where I needed my cache. Okay. So here's the mistake I'm making here. Stop. But I don't. Give me a second. I'm tripping up because I feel like this should work. Um, this should work though, because like I'm not exiting early. Because it's for each towel. I'm just saying if it starts with it, then we search deeper, right? Else we do 0. So real quick, let me just make sure that I do have my part 1 working again. If secondary cache dot contains key starting index, return false, because I can do that. Um, right. Okay, so I'm getting the right result here, but somehow I'm getting a different result down here. Real quick, I'm going to test something. Looking at my input, how many inputs do I have? Okay, so I have 4 inputs that are a single letter. What's my... Oh my fucking god. Oh my god. Although that still doesn't explain my other issue, but I'll deal with that another time. Um, oh no, it does. It does. Oh my, it this needed to be a long. That's the problem. The problem is that needed to be a long. The classic Advent of Code problem is shit needed to be a long. Oh, a herpy derpy doo, a herpy derpy doo. Why don't you like this? Yep, it needed to be a long. McBurney, you are stupid. I was right. My code was right. It just, minor details of like actually knowing what the fuck I'm doing. All right, I'm gonna work on 17 part 2 today. I'm gonna solve this. I've spent so much time thinking about this, and I've been trying to reverse the algorithm, but the problem is those damn damn um modulus. It's not like so. All right, let's talk. So yeah, day 19. Woo. Not like it. How long did that take me? How long have I been streaming? 42 minutes. Okay, so that would not have been a good time, probably, regardless. Um, I mean, obviously, I don't know. Right. There's no easy way for me to know how long it is, but yeah. And again, this is just, hey, I started like this one. I had to sleep, and these ones I was doing exam and grading and stuff, and this one I slept, and this one I slept. So, you know, oh well. This one was pretty easy though, and I just got caught up on a stupid bug. I need to train myself, just be in the advent of code mindset of every integer is a long. I need to just beat that into myself with anger and fury and self-loathing, and then and only then will I be a good programmer. Is when I hate myself. That is a lesson for life, by the way. Because if you love yourself, truly love yourself, you're going to think you write code without bugs. You have to hate yourself a little bit. Not completely, like a little bit of self-hatred. You need that to be a good programmer. I am joking. For the love of God, please understand that I'm joking. Um, I don't actually hate myself. I just talk to myself uh, like an idiot because that helps me find bugs better. Probably some kind of underlying neuropathy of some form. Anyway, all right. Thanks for watching.